Hello Year 10. This is a video about the higher paper Year 10 PPE. Okay. Now, a lot of you have submitted it and done brilliant jobs in lots of different ways. Doing it on a scrap piece of paper, doing it in an exercise book, doing it in some kind of Word document or a notepad or some kind of way of submitting the work to your teacher, which is wonderful. Some people find it really tough to be able to access it without having a piece of paper in front of you to actually do the test. Which is okay. Try not to get stressed by it. Okay, we're just trying to make your time at home as useful as possible. So if you haven't managed to submit the test, don't get too stressed. Okay, go through it either now or go through it with the mark scheme that now is live on that same link that your teachers have set you. So initially it was just the questions. Now you can click the mark scheme tab and it will bring you to this mark scheme. Okay, so I'm going to go through some of the questions. I'm not going to go through them all. I'm going to go through some of them. Now this first question is quite tricky. You need to know properties of series and parallel circuits. And the thing that's tricksy is that it gives you this milliamps. You need to be really careful when you see units like this. Okay. If I was doing this paper, I would circle it or highlight it just even before I read the question, just because I know it probably will come up that I might have to change this from milliamps into amps. Okay. Now, the important part of this is it tells you that it's a parallel circuit. So at these junctions here, the current will split up. So if we start with 186 milliamps, it will split up between P and Q. Okay, and you'll get 96 milliamps. Okay, sorry, no, 93 milliamps going between those two junctions. So 93 going through P and 93 going through Q. Okay, but I don't have an answer of 93. Because all these are in amps. Like I said, I've got to change those units. Okay, so the answer is 0.093 amps, just like it says in the mark scheme here. Okay, the rest of the question is pretty straightforward. This you've got to make sure that you describe and then explain. So you need to say, okay, so what happens when this resistance increases? The current will drop. If the current goes down, the brightness will decrease. Okay, you've got a higher resistance, the current drops, the brightness will decrease. Okay, this we need to know the equation. If you don't know the equation, you'll drop 4 marks. Okay, you need to know V equals IR. Potential difference is current times by resistance. Okay, you need to know to be able to sketch the filament lamp and the diode and a constant resistor, a fixed resistor. This one is not a straight line, it's a curved line. It curves, not a constant gradient. Let's move on to question 2. It's got about momentum. Again, you need to know the equation. You can write it as letters or as words. P equals mv, or momentum equals mass times velocity. Simple substitution in here. This question, this part C, I want to focus on a little bit. Explain what happens to the velocity of each of the skaters. So we've got skater A, okay, travelling along, bumps into skater B who's stopped, stationary. The skaters move off together in a straight line, so they're going at the same speed. Explain what happens to the velocity of each of the skaters. Use the idea of conservation of momentum. It's the first thing I would do when I see that. Okay, they need to know that, so I need to write it down. So I need to write down conservation of momentum, which is really important. You really need to know that. The conservation of momentum means that if the momentum at the beginning of something is the same as the momentum at the end of a collision. So the momentum before something happens is the same as the momentum after something happens. Okay, it might be shared between different objects in different ways, but the total momentum before has to equal the total momentum after. And I bet, yeah, that's the first mark. The total momentum before the collision equals the total momentum after the collision. Okay, and then you just say what happens to the speed because of that. Okay, well if before the collision B is stopped and then B is moving, B is going to get faster. Okay, B's speed will increase. But if B's speed is increased, it's going to have some extra momentum and it's going to have taken that from skater A. So skater A's speed has to decrease. Okay, so you can either go along the route of the momentum of skater A decreases and the momentum of skater B increases. So the velocity of skater A decreases and the velocity of B increases. Or you can say the momentum of skater A decreases, so the velocity of A decreases. Or the momentum of skater B increases, so the velocity of skater B increases. Okay, so you need to have first what the conservation momentum is, and then how it will affect the speed. Okay, so move to question 3. Question 3 is pretty straightforward, about Hooke's law, about stretching of springs. This is a 0 error. Okay, start it not at 0 to 0 error. This one is tough. This is a difficult calculation question. It's 6 marks. If you have a 6-mark calculation question, you will need to use 2 formula. Almost always it will be 2 formula. Okay, or it'd be a particular difficult rearrangement where you have to take lots of different numbers. But normally, if it's 6-mark calculation, it will be 2 equations. Okay, so the first thing I would do about answering this, I'd highlight what I know, and I'd write down some equations at the side here. Okay, so I know the spring constant equation, F equals KE, force equals the spring constant times by extension, and I know the energy equation for it. Energy equals half times by K times by E squared. So the energy equals half times by the spring constant times by the extension squared. So the first thing I can do, I can use the energy, 4.5 times 10 to the minus 2 joules. Okay, that will equal whatever my spring constant is times by half times by my extension squared. Now I can find the extension of that spring based on how much of that first weight was. Okay, and using that, I can then figure out the next part. So if you look at the mark scheme, so the first thing it does, we've got that formula. Okay, the kinetic energy equals half times by the spring constant times by E squared. I rearrange this, be careful of the squared, so putting the square roots here, putting these numbers in brackets, okay, or using BIDMAS, I think you use, not BODMAS, BIDMAS, to be able to use calculate properly to get the answer. And your extension should be 0.015 meters. Okay, so when they put that first weight on, it stretches by 0.015. Then they put the extra 2 newtons on. They increase the force. Okay, now if I know what the force is, I know what my spring constant is, I can find an extension. Okay, so I can do that section. 2, which is my force, equals the spring constant times by the extension. This is the extension for the second weight. Then the last mark, we need to add those 2 extensions together to get the total extension. Okay, the initial plus the additional one. Okay, it's a really difficult question, that, but there's lots of places where you can get the marks in it. Okay, lots of places where you can get the marks in it, even if you maybe rearrange this equation wrong. So even if you got this step right, but you got the wrong answer for the extension, and maybe you got the wrong, you couldn't remember what Hooke's law was, and you could write down an extension here. So say you got 0.02 and 0.05. Even if you just add those together, you can still get that extra mark. So you can still get 3 marks even if you get the actual answer wrong. Okay, there's lots of ways you can be picking up marks in this question. Okay, all right, let's move on to question 4. This question, lots of it is recall, knowing the difference between longitudinal transverse waves. Write the definitions, talk about vibrations perpendicular to the direction of travel or parallel to the direction of travel. Here, it's simple calculation. Okay, you need to know the equation that links wavelength, wave speed, and frequency. V equals F lambda. Okay, very lambs is where you can remember it. This last question, lots of you have not got the marks for. There's lots of guessing and wasn't answered, generally speaking, very well in the papers that I've looked at. Okay, this is knowing some of the properties of the electromagnetic spectrum, knowing how radio waves work, know how they're emitted and how they can be received. Okay, so you need to know that the radio waves hit the aerial. Okay, so the aerial absorbs the radio waves, or the energy from the radio waves. That means the electrons in the metal area will move, they will vibrate in that aerial. Okay, if the electrons are vibrating, they're creating an alternating current. Okay, there's an AC current, alternating current in the aerial, and that frequency of that current is the same as the frequency of the radio waves. Okay, so first the aerial absorbs the radio waves, that causes electrons to vibrate, that creates an alternating current, that has the same frequency as the radio waves hitting the aerial. Move on to question 5. This is a little bit of a tricksy graph here. So we've got distance in meters and time in seconds. And we've got the driver is tired. His reaction time increases from 0.5 to 0.82 seconds. What's the extra distance? Okay, so it says determine. You don't need to calculate. Now you can calculate based off of the speed, but it's easy to just read off the graph. Okay, so we go up at 0.5. We go up at 0.82. Okay, and we look at the difference between those two things. Okay, so we've got 0.75 and 12.3 from the graph. Now when you do it in the exam, in the real one, draw lines on the graph in pencil. The examiner can give you marks for using that. Okay, now in this case you might not get the extra marks just for using it, but if it was a 3 or 4 mark question, you might get a mark just for showing you're using the graph in the right way, even if you've actually got the wrong answer. Okay. Brakes are used, temperature of brakes increases. Why? Think about friction. Think about the transfer of energies. Okay. Then we've got using this equation sheet. So I sent that out with an announcement. So if you didn't get this question because they sent the announcement a little bit late, don't get too stressed about it. But this is just substituting into the equation. If you didn't get this right, you need to practice that equation. Okay, now this graph, this is a 6 mark writing answer. This is pretty tough. Okay, initially there's lots of information and it appears pretty difficult, but it's actually not that. It's not that hard really. It's just given to you in a little bit of a confusing way. Okay, so you've got this graph that shows speed, distance. You need to figure out. Okay, so what's it asking me? Okay, so So this graph shows thinking distance, braking distance, and stopping distance. So how are those three related? Forgetting about the graph, you should know that. You should know that the stopping distance is the thinking distance plus the braking distance. And you can kind of see that this plus this gives you that. And it says, describe the relationship shown in figure 2. So you need to talk about the different patterns in the lines and how the three are related. Okay, and you should talk about factors that affect the lines. Okay, another way of saying that is, what are some of the factors that affect thinking distance? What are some of the factors that affect stopping distance? What are some of the factors that affect braking distance? Okay, not too difficult, just a bit of recall. So they're looking for things like use of drugs, alcohol, tiredness, distractions will increase the thinking distance. Thinking distance increases with speed. Okay, as the speed goes up, thinking distance goes up. Okay, thinking distance is directly proportional to speed. Okay, poor brakes, wet tyres will increase the braking distance. Braking distance increases with speed, but it is not directly proportional. It's a curve. Okay, it increases with the square of the speed because the energy of the car is the kinetic energy. And the kinetic energy increases with the square of the speed. Okay, then stopping distance is thinking distance with braking distance. Factors that affect the thinking or the braking distance will increase the stopping distance. Okay. So all things like that. So it's quite a tricky question on the front, where it looks a little bit confusing, but there's lots of information that you should know that will get you marks. Okay, lots of information, and you can get marks just from describing the graph. 6, last question. This one is somebody falling out of a plane. Would you believe it? This is all about terminal velocity. We've got force A, force B. They're balanced. There's no resultant force. The acceleration is 0, constant velocity. This helps you answer this question. Constant velocity when the forces are balanced. If they're not balanced, if A gets bigger, okay, if force A is bigger, then the person must be accelerating. Okay, so first he will accelerate. That will cause the resistance to increase, which will cause the acceleration to slow down. Okay, and it will increase, force B will increase until it matches force A again, and the swimmer will arrive at a new higher constant velocity. So man will accelerate, force B increases until it's balanced with A, which will result in 0 resultant force, which will cause the person to have a new higher resultant, constant velocity. Here, kind of a tricky question here. You need to figure out the scale. So I would just do a really simple scale of, for every 5 little squares, I would have 1000 newtons. So we start at any point and we go along 3 and we go down 1. And we join up and make that triangle just like it's shown here. Okay. I hope you've been working well at home. Take care. Goodbye.